over some additional functionality found in Pandas. And let's start off by, let me zoom in here. So we load up our modules, and the first thing we're going to look at is something that you might be familiar with if you've ever dealt with databases, and that's the join operation, which essentially takes a table of data, which in Pandas lingo means data frame, with another table and puts them together. Now let's start out with setting up a df1, a data frame that has two columns, key and data1, and then another one that has the key column again, but now it has a different column as an addition called data2. Now, if by default we just merge them with pandas merge, and by default I mean the default options which you can see in the documentation here. You see there's a lot of different options, but if we just do the default, what's going to happen is that Pandas will look for the common column, which in this case is key, and it will look to find the common values. So you see here that we have A, B, those are also found here. C is found in df1 but not in df2, and D is found in df2 but not in df1. So the resulting merged data frame will have only A and B, because again they're found in both of them. And you'll see that for A and B we've got the B which has 0 and 1. This is one of them, and this is the other. So it merges that row with this row. Then this one, the B11, merges this row with this row. B61, there we go, 6, and then merges it with this row. And again, you get the picture. It just finds the combination of the rows that have the common values in the common column. As I mentioned, again, there's a lot of different options, and the default here is the inner join. There's also cross join, outer join, left and right join. More likely what we're going to do is we're going to merge on the indices. So for example, if we set left index true, right index true, what's going to happen is that you will only grab the 0, 1, 2 and the 0, 1, 2, and it will give us, you see how it created suffixes in the column, so we get both a key X, key Y, because again we joined on the column, on the index. So play around with the different options that you have, and you can see that you can have a lot of power in terms of merging data frames. In similar operation, but something that we've seen with NumPy, is the concatenation, and this is done whenever we want to stack data. So for instance, if we have 3 series, so you see here that we have an index A, B, C, D, E, F, G, and we just want to put them together. By default, we're going to end up with the pandas concat, and we're going to have the indices everywhere and the values that correspond to them. But we can also do that in columns. So you see we can set axis equals to 1. And now you see that we've done something different, where essentially we're using the values from here to create columns. Right? So you see here basically that we have 3 columns. So we have the values here, 0, 1, that's column number 1. We have these 3 values here, and we create column number 2. And according to the labels, we put missing values in places where each of these series did not have any data. So now we get to the interesting and more exciting part, which is the data aggregation, and we'll be doing a lot of that. And you've usually dealt with some sort of situation where you had to combine data, group them, and apply a certain function. So for instance, let's say you had daily temperature data and you wanted to find the seasonal averages. So that is split, apply, combine operation, as it's called, again in Pandas, where we split the data set according to some specification. And in the case of the example I just mentioned, we have seasons. So we split the data into seasons. Then we apply a function, and again, in the case of the example, that would be the average. Then we can recombine the data. And by recombining the data, we can either end up with the same size, or we can end up with smaller sizes. And usually that's the case. We end up with smaller sizes. Which again, we've had like 10-year time series. We have 3,650 or a little bit more with leap years of values, but with the seasons, we'll end up with the 4 values. And this is a schematic here that kind of shows how this works. And the nice thing about pandas is that we can split according to different criteria. Most likely, we would be looking at the key or the index. Now, let's look at this in practice. So let's start out with a data frame that has multiple columns. So you have 4 columns. We have the default index. And let's assume that we wanted to calculate the means of data 1 column, grouping by the key 1 labels. And you see here, key 1 is A and B. So we wanted to get the means of the A group and the B group. So the first thing we were going to do is going to use the group by functionality. So we pick the column, data 1, df data 1, and then we remember everything is an object, so we have dot, and we can call a function. So dot group by, and then we group by the column key 1. And if we look at what we get, this is, well, and this looks like not the values we wanted to see, but it's an object. And it's called a generic series group by object. So this object does have attributes, so the data are hidden. So the data are there. We just don't see them when we just print out the grouped object. So if we wanted to, so this basically did the split part. It hasn't done the apply part yet. Remember, split, apply, combine. So if we want to apply, then we can, on this object, we can call the mean function, which also does the combination part. And here you can see we get the mean of A and the mean of B. So we went from 5 rows to 2. And there's a lot of flexibility in how we can define this group by specification here. In this case, the first case, we used a column. But we can also do things like use multiple columns. So for instance, we can use both key 1 and key 2. Let's go back and see them. We have key 1, key 2. What this is going to do is going to create all the combinations available between these. And most of the time, we don't do it separately like here with grouped. We just chain the operation. So we have the column, we do the grouping in one operation, and then again, this is an object, so another dot, and we get the means. So now you see that we have dual indices, so A1, A2, B1, B2, and the means of each of those groups. And we can also have any sequence we want in the group by specification. And it doesn't even have to be a column in the data frame itself. It can be something external. So as long as there is the same number of labels as the number of rows, we can just group by states and years, for instance, get the mean. Let's try that. You can see we have 5 labels, right? And we go back to our data, it's 5 of them. So as long as they're there, this will work. And we get California 2005, California 2006, and so forth. So again, hopefully, even this simple example gives you an idea of the flexibility and robustness of the group by specification. So let's continue on with the grouping part. And you can see that here we can do it with dictionaries or series themselves. So let's start out with an example data frame that has 5 columns, has index of 5, and I'm going to just set some missing data. So you see here, we've got names as the index, we've got some columns, and then some random numbers, and we also set some missing data. Now, if we have a color corresponding to each letter A and F, so here let's set up the mapping, A red, B red, C blue, and so forth. You can play around, and this can be anything obviously, but this is a dictionary which we have named mapping, and there's a reason why we use the variable name mapping for it. Because what we can do is we can group by the people data frame with this mapping. And what this mapping does is it looks at the columns and essentially groups each column according to the color that we set up. So as you can see, this should grab the A column, the B column, and the E column and have them into one group. So it splits the data frame into three groups, the red, the blue, and the orange. And it grabs the equivalent, the corresponding columns. And usually this works on rows with the index, but because we've set up axis 1 here, it means that we're going to look at it along the columns. So if we group by column, and then we take the sum, we've got blue and red. Now where's the orange? Well, it's not there because there's no F column. So even though the mapping has that specification, because it's not found in the data frame, it's just not going to show up in the final result. So as you can see here, we're essentially keeping the index, but then performing the grouping along the columns. So for Joe, for instance, we are summing the A, B, and E columns. So we've got, minus 0.8, minus 1.1, and then plus 1.1. And we have to trust the computer that this actually comes out to minus 0.822. So now what we're going to do is I'm going to skip this part here, which we can do in class, but I'm also going to talk about grouping apart from dictionaries. So we saw that we can do grouping with columns, with a list, but also with a dictionary and with a function. So again, let's take a look at our people data frame. And then suppose we wanted to group by the length of each name and calculate the sum. So as you can see, we've got the length of each name, right? So now we're working on the index because we don't have the axis keyword set to 1. So Joe has 3 characters, Steve has 5 characters, Wes has 3, Jim has 3, and Travis has 6. So essentially we're going to end up with 3 groups, right? We're going to end up with a group that has 3 characters, one that has 5, and one that has 6. And that's very easy to do in Python because we can just call the function. And Python and Pandas specifically will apply this function to the index in this case, and then whatever the function returns, that is the specification that we're going to use to group the data and split them. Then we apply and combine with a sum. Let's take a look. And there it is, 3, 5, 6. So 5 should have the data from Steve. There they are. So there was nothing else to sum, so the sum of the individual column here. Now we can also do the same thing, but combine. So as we saw before, we can use multiple key columns, but now we can also combine, mix and match functions and dictionaries. Now you see we end up with 3 and 2 groups, 1 and 2, 5 and 1, 6 and 2. So this only really touches the surface of what we can do with grouping. And you'll see there's a lot of different options, but the fact that you can use columns, lists, arrays, dictionaries, or functions, again, gives us a lot of flexibility in how we can do these operations. And now, where we apply these, I guess, in our field of work, is with time series. And because that's so, you do this sort of thing, the grouping for time series, way too often, Pandas has a whole set of functions that are specific for time series. So let's take a look at that. The nice thing is that uh, time series have um, some properties that are not available in some generic data frame or series, right? For example, we have frequency. So Pandas understands what the frequency is, if it's daily, monthly, biweekly, and so forth. And there's also some other functions or terminologies, like for instance, resampling, that is only available for time series, and Pandas understands that. So during class, what we're going to do is we're going to go through the hands-on exercise. So we're going to essentially apply the group by mechanics that we looked at before, but now for time series. And you'll be able to download this file from Moodle, and we'll be able to work on that.